Hey guys, welcome to Deep Dive Coding. Today we solve LeetCode problem of the day. In this video, I will give you the simplest and optimal approach to solve this problem, that is balanced binary tree. So in this video, I will go through this way. First explain the questions, then go to the intuition part, code explanations, dry runs, and finally complexity analysis. So I will attach these things in the chapters so you can skip particular portions. Now without further delay, let's start the video. So given our questions, we are given a binary tree, and this is a binary tree, and the task is given determine if it is the height balanced binary tree or not. That means binary tree means there is a root node, and that it can have the left child and it can have also the right child, or may not have the left and right child. It can have only left child, or it can have only right child, that is also fine. In that case, you can consider if the root node is this one and its left child is not there, you can consider it's a null, and if it is right child is not there, it will be also null. Okay, so the task given is height balance. Now what is height balanced? I will explain that thing. So height balance is a binary tree in which the depth of the two subtrees of every node never differs more than one. What it mean? Let's jump into our tree. We want to calculate this node height. So it's have the subtree of this portion. This is the one subtree, and this is the another subtree. So you can say this is left subtree and this is right subtree. To calculate the height of this node, you can do this way. That means there is only one node present over here. So first of all, its left subtree's height would be 1, and its right subtree there are two depth, like this is first level and this is the second level, or you can consider this is the first level and this is the second level. So for the right subtree the height would be 2. So when it comes to this node, root node, it will take the input as 1 for the left subtree and 2 for the right subtree, and if you subtract and you get the plus 1, because here plus 1 and here also plus 1, because you need to counter, like consider this root node also. So it will be like 2 and this will be 3. So over here it says not more than, but it is acceptable if it is less than or equal to 1. Over here it is difference is 3 minus 2, or you can take absolute value of 2 minus 3, which is lesser than or equal to 1. This is balanced subtree. And if you consider this node, let's calculate for this one, that is the second example of LeetCode. So for the right subtree, there is the height is only 1. For the left subtree, if you take the maximum depth, that would be this is first level, second level and third level. So this will be the 3, like left subtree, this is the left subtree height would be the 3. So if you consider this root node, so it will be like for left subtree it will be 4, and for this one it will be 2. So if you take this difference of these two elements and take the absolute value, that means absolute of 4 minus 2, is it lesser than or equal to 1? No, it's not. It would be like 2 lesser than or equal to 1, which is not. So this is not the balanced subtree. So I think you got the answer question correctly. Now come into the intuition part. So we need to check the height for every node, because if any one node height balance is fail, that means total tree is failed. That what I mean is, let's say over here it balanced, this is the balanced, but if you need to count this one, now it's not balanced, because first this level fail, then it will fail over here, this node, for this node. So you need to check for every node height should be balanced. To get that height, we need left subtree calculations and right subtree height calculations. And like acceptable condition, you can say left height and minus right height, we take the absolute value, that you can say mod should be lesser than or equal to 1. So either it can be 0 or 1, because negative is not possible. You can consider for the calculations of height, that would be like maximum of left height and right height, whatever is the maximum, and plus 1 for the that particular node. That means let's try to calculate the height of this node. So you consider for left subtree height is 1, and for the right subtree height is also 1. 1 for right subtree it will be also 1. So when you calculate the height for 20, its height is 1 plus maximum of left height, that is 1, and right subtree height, that would be also 1. So total height would be 2. So it will return the 2 height of these portions, this subtree part. Now if you calculate these 3, then left subtree give the height of 1, and also right subtree give the height of 2. We already calculated that. So you get the height of for this node 3, you can consider h of 3 for the third like root node of this one. So 1 plus maximum of left subtree height, that would be 1. So 1, and right subtree height, that will given as 2. So it will be 2. So you consider 1 plus 2, so it will be like height of 3. So you get the this node h of 3, you can consider this node height is 3, and this way you can consider the height. So I think you observe a good thing, like you consider this way a binary tree. Let's take a random example. You consider 2, 3, 4 and 5. So if we want to calculate the height of this node, we need to know the height of left subtree node and right subtree node. And if you again check for height of this node, we again needs to take left of like needs to take maximum of left subtree node and maximum of right subtree node height. So you can consider this is a recursion problem, like each time we land a particular particular node and calculate left subtree height, and calculate right subtree height. So this way you can consider this is a recursion approach. So this is a simple recursion. If you are able to write a recursions problem, like if you do the sum recursions problem, then you can easily write the coding part. Now let's come into the coding part. So we are first defining answer, that is boolean answer equal to true. We just pass this variable to the height functions, and in the height functions we pass the root and the answer, that is boolean part, and at last we just return answers, that means whether it is possible to balance or not. So initially we are taking that is as true, because if none of the height is balanced, like if the root node root equal to null, that means there are only one node that is not that is null. So this is the root node, so this is also balanced, like there is only one node and no left subtree, no right subtree, so it is balanced, as question is also given. So now let's come into the height function. So height functions take the tree node root. So this root is this way, that means let's say you have this one pointer to the root, and if you take the root left, then this will give you the root left node, that is left child, and if you consider this one, then it will be root right, that will be pointer to the right child. Now if the root equal to null, what it means, that means there is only one root, or you try to access a root that is not like defined, so that is empty, so you just return 0 because it is false, it's not possible. So you can consider let's say you have the test case this way, that means you have only one node which is not initialized, you can consider it is null, then that means root equal to null. This is you consider okay, so root equal to null, that means if the height here over here its boolean is true, and if you pass in the height functions it will give you the return 0, that's nothing do with the answers, so answers is true, that means actually correct. That means in case of it is null only one root, then answer is also true. That is the case to handle over here. Now consider the, now calculate for, now we are in particular node. For a particular node we need to calculate the left height and right height using the formula like 1 plus for consider the current root plus height of the left child. You consider is it will be calculate the left subtree part height, and for the right height you just consider the current root plus height of the right subtree that you can access via root right, root arrow right. Now it's recursively call all the functions until it's go to the null point. If it's hit the null, then it's give the 0, that means you are in the leaf node. Let's consider this is a leaf node, let's this way. Okay, so 2 and 1, these 2 and 1 are the leaf nodes, and if you try to access these nodes via left and right pointer, then it will give you the null. Over here also null, over here null, and over here also null, so it should return 0, that is over here written, and it should also return the height of 0, this should return height of 0, and this should return height of 0. So this is the case of the base case you consider for the recursions, and as it hit the null root, then it will simply give the 0 as the height, that is actually correct. Now try to calculate the condition part. So absolute value of left height minus right height, if it is greater than 1, that means condition is not true, so we just update the answers as false and return 0. That means this 0, even if we return 0 over here, this 0 it does not mean anything, because we find that for a particular node the left height minus right height absolute value is greater than 1, that means we consider this is a this is not balanced, and we do not need to check further. And if this condition does not hit, then we just return the maximum of left height and right height. This will give you the, for the current root node, it will give you the actual height of this one. I think the coding part is clear. Now let's try to dry run for an example. Let's run an example for height function of 3. We start from the root node, this is the root node given over here, and it will call two things like left subtree, that will height of 4 will be called, and height of 5 will be called, and whatever it is given we just return 1 plus that one, and over here also 1 plus okay, just let's try to return it this way, that it will return some value and it will also return some value, and we try to take maximum of 1 plus maximum of these two things, like this value and this value. Now when you try to calculate height of 5, it try to access left pointer which is null, that will be, you can consider, let's only write h of null for left pointer, and for the right case h of again null. So it will hit the base case, it will give you return, it will return the 0, and over here also 0. When it's return 0, and when height of 5 it's count itself, so it will try to calculate 1 plus max of 0 comma 0, so it will give you the 1 as answer for right subtree of 3. And now let's try to calculate for the height of 4. Height of 4 will again call height of 8, and right subtree, that would be height of 9. Now height of 8 will call its left pointer, that is null, so you can consider h of null, height of null, and again right pointer again h of null. So it will give you the 0, it will hit the base conditions, it will give you 0, and it will also give you 0, and it will try to 1 plus max of 0 comma 0, then it will return 1 as a height. So you can, I will write over here, it will return. So similarly 9 also try to access the its left pointer, that will h of null, and right pointer h of null. I am smaller way to write h because it will be actually height of null and height of null, that means it's try to access these things, null null. Okay, and it will hit the base point, like base case, and it will return the 0, and it will also return the 0. Now it will try to calculate 1 plus max of 0 comma 0, and it will return the value 1. Now 9 also return the value of 1, and 4 will decide is it balanced or not. That means absolute value of 1 and 1 will give you the 0, that is balanced, because 0 less than equal to 1. Now these recursions is done. Okay, these recursions is over. Now it's try to call the like try to calculate this one, height of 4, because height of 4 already get the left subtree part and right subtree part. So now height of 4 will give return 1 plus max of 1 comma 1, so that is actually 2. So it will return 4 will return 2 to the over 3, and 5 return to the 1, as I already discussed over here. Now 3 will return the its height. What it mean? That means 1 plus maximum of 2 and 1, that will give you 1 plus 2, that will be actually 3. But before return the height, it will first calculate is it balanced. Yes, it's balanced, because modulus value of 2 minus 1, it is give you less than or equal to 1, this is actually true. So yes, it's balanced, and it will finally return the height of 3 to the answer. Now as the answers is not like height is already balanced all each across the nodes, so answers written over like given over here 2 only. If in any case the height is not balanced, then we just return the answer as updated answer false. Now let's come into the complexity part. So for here we just try to access all the nodes one by one. So you can consider the number of nodes, n equal to number of nodes, number of nodes. So you can consider it will be give you the big of n time complexity. And for space you can consider for each of the, like for a current node, let's consider this this way. For a current situations, like at we just try to access this one, so we recursively try to compute this one, and again recursively compute try to this one. So you can consider whatever the height of the tree that we are in the recursion stack space. So you can consider this will be bigger of h, where h equal to tree height. This much extra space needed to calculate the recursions. Thank you guys, thank you for watching, stay tuned for more videos, and if you like it, please like and subscribe the channel.